Research of this kind is being stepped up worldwide. The need to understand the interplay of atmosphere and oceans has been given a new sense of urgency by the realization that our energy-consuming way of life may be causing climatic changes with adverse consequences for us all. Since 1850, the consumption of these fossil fuels has increased 100-fold. Add to this the more recent burning of the tropical forests, and the result has been a marked and accelerating increase in the amount of carbon dioxide in the atmosphere. What's more, there's been an even sharper increase in other, even more potent greenhouse gases, which absorb energy at different wavelengths, retaining even more heat in the atmosphere. Nitrous oxide and ozone, mainly from traffic. Methane from cattle and rice fields. And new to nature, the CFCs, used as blowing and cleaning agents and refrigerants. These other gases could soon be absorbing as much radiation as carbon dioxide. But has this started to make the Earth warmer? Weather is hard to predict, but records of its past behavior go back a long way. Fertile ground for the revealing eye of the computer. Region-by-region analysis of world temperature records shows a small but significant warming trend over the century, with a marked increase in the 1980s. Reduced to global averages, it shows a rise of just ½ a degree Celsius. This could be due to some natural climatic change, but it does accord with computer models based on the known atmospheric processes and predicted buildup of the greenhouse gases. These models contain many uncertainties, but they forecast that by 2050, global mean temperature could have increased by at least 1.5 degrees, possibly near 4. What the computer modelers are looking at is the possibility of change at a rate faster than at any time since the end of the Ice Age. Change too fast, perhaps, for life to adapt without severe dislocation. What they foresee is not a steady and even warming overall, but alterations to the familiar patterns of climate and the increasing frequency of abnormal weather. Their strange, mesmerizing images of possible futures have each prompted the same serious warning. A warning endorsed by a uniquely broad consensus of scientists in their report to the United Nations at the end of 1990. By that time, early predictions that rapid melting of the polar ice caps would inundate coastlines and drown major ports and cities had given way to a less apocalyptic vision. Instead, a slow rise of 1 meter or so over the coming century. But even this could be disastrous. Tropical islands, barely afloat even now. First made uninhabitable, and then obliterated beneath the waves. only safe insurance. But what should that action be? Down there, in the real world of the here and now, 1 billion people are intent on maintaining their high standard of living. 4 billion more trying hard to catch up with them. For years, the harnessing of various forms of energy derived from the sun has been written off as uneconomic or of limited application and value. But new technologies and courageous investment have brought a change of perception. In California, solar heat has been successfully harnessed to provide electricity on a commercial scale. So has the power of wind. Can emissions of the greenhouse gases, particularly carbon dioxide, be cut back fast enough to provide that essential insurance without blunting the forward thrust of development? In a world of nation states, could such a global target be agreed, let alone achieved?